Namaste and a very good morning to all of you. My name is Mithun, and in today's topic, I will be talking about independent samples t-test. But even before I talk about independent samples t-test, I request you to subscribe to my channel and share my videos with your friends and relatives. What exactly is independent samples t-test? Why and where do we use independent samples t-test? In simple language, independent samples t-test helps me compare the performance between two groups. Whenever I have two groups and I want to compare whether the average performance is the same or is it different, I can use independent samples t-test. I'd like to give you 3 or 4 examples as to where independent samples t-test is used. Suppose you're an agriculture scientist and you want to check whether the average yield per hectare is the same between two states, namely Andhra Pradesh and Karnataka. You can go ahead and use independent samples t-test. Secondly, if you are in the field of education and you want to check whether the pass out rate between boys and girls who take up the 10th standard board examination is the same or different, you again can use the independent samples t-test to compare the pass out rate between boys and girls. Thirdly, if you are in the field of web analytics, you might want to compare an existing version of the website with that of a new version for key metrics like the average time spent on the landing page per session and also the conversion rate. Nextly, if you're a pharmacist, you might want to compare whether the average blood pressure between the placebo group and the treatment group is the same or different. So maybe the field of A/B testing, which is called as bucket testing or split testing, maybe in the field of pharma, or maybe in the field of HR, maybe in the field of education or agriculture. Independent samples t-test has a wide range of applications. So let me show you how we can conduct the independent samples t-test in Spss. What you're seeing in front of you is a Spss screen. Let me pull out some data to illustrate how independent samples t-test works. I'll go to the file menu, choose recently used data. Spss displays 10 recently used files. I will choose the very first one, employee data. As you can see here, this is the employee data set, and it has 3 variables. The first variable is ID, second is gender, and the third variable here is salary. So this is the scale variable, and I have got a categorical variable in the form of gender, which has 2 categories, males and females. What is the sample size in this data set? The sample size in this data set is 474. I want to compare whether the average salary between males and females is the same or is it different. How do we do this? I like to do this in 2 stages. In the first stage, I like to do EDA or exploratory data analysis. And in the second stage, we can look at the independent samples t-test. When we talk about EDA or exploratory data analysis, typically people use either a bar plot or a box plot. I will be using the second option, namely the box plot. As you can see here, this is the graphs menu. The very first item here is what is called as chart builder. Let me click on this particular option. And at the bottom left-hand side corner, you can see a whole lot of graphs like bar chart, line chart, area chart. I will choose the option box plot. The very first option here is the simple box plot. You have the y-axis and the x-axis. In the x-axis, I will drag and drop the variable gender. And in the y-axis, I will drag and drop the variable salary. So I've got salary in the y-axis, and I'm comparing the distribution of salary between the males and the females. This will produce a simple box plot. Let me click on OK. Spss shows us the distribution of salary between the females and the males. To dress up this particular box plot, I will double click on the box plot. Once I double click, you can see the chart editor window opens up. You can choose the box plot. Once you choose the box plot, you can right click and then click on the very first option, namely properties window. Here, I will change the color to red and then say apply. You can see here the color of the box plot changes. Nextly, I can click on this particular tab which says bar options. Here, I can increase the width of the bar to around 70. Then say apply. You can see here the width of the box basically changes. Let me close this particular properties window, close the chart editor window. Now, this is how the box plot appears. There are two important observations that we can make. First, this thick line is what is called as the median, and the median salary for males is higher as compared to the median salary for females. What is the second important point? Look at the length of the whiskers for the males. Compare it with the length of the whiskers for the female category. As you can clearly see here, the spread, the length of the whisker shows us the extent of dispersion. So there is more dispersion in the salary for males as compared to the dispersion for the salary amongst the females. So two important observations here would be that on an average, the males are paid higher as compared to the females. The variation in the salary for the males is higher as compared to the variation in the salary for females. Of course, you see a few outliers for the males. Similarly, you also see quite a few outliers for the female category. So the averages are different. The spread is also different. These are the 2 points that I can infer from the box plot. The question here is, are these differences real or is it happening by chance? To answer this question, whether these differences are real, is there any statistical evidence for me to conclude that on an average in this organization, males are getting paid higher as compared to females? We have to move on to what is called as hypothesis testing. And under hypothesis testing, we can use the independent samples t-test. Why independent samples t-test? Because we are comparing between two groups, namely the males and the females. To conduct the independent samples t-test, I will go back to the data editor window. Here, let me click on the analyze menu. I'll choose the fifth option from the top, which is called as compare means. And within compare means, the third option here is independent samples t-test. Here, once I click on the independent samples t-test, a new dialog box opens up. I have to specify the test variable and the grouping variable. The test variable here will be the scale variable, namely current salary, and the grouping variable is gender. I have to be slightly careful here because after making these selections, the OK button is not highlighted. Now, to ensure that the OK button is highlighted, what I need to do is go to define groups. This is the tab which I will be using. Let me choose the define groups. Group 1 would be F, which is males, and group 2 is M, which stands for males. Why am I not specifying 1 and 0? Please look at the data here. This is gender. Spss does not allow me to look at the value labels, but here in this data set, females are coded as F and males are coded as M. I'll choose continue and then click on OK. Now, this is the output of the t-test. You can see two tables. One is the group statistics, and the second one is the output of independent samples t-test. What does the group statistic tell me? There are 216 females and their average salary is 26,000. the standard deviation is 7,558. When you compare the female category with the males, there are 258 males, their average salary is 41,451, which is almost $15,000 higher as compared to the females. When you look at the standard deviation also is higher for the male category because it's around 19,499. But when you look at the standard deviation for females, it is 7,558. Standard deviation is a measure of dispersion. Standard deviation being higher for males indicates that the dispersion in the salary for males is higher, which is what we saw in the earlier graph. That is, the variation in the salary is larger, is higher for males as compared to that of females. Now, are these differences real? Now, this is the substance of the matter. Now, you can look at the heading here, independent samples t-test. Is there any statistical evidence for me to conclude that on an average, the males are getting paid higher as compared to the females? I have to be very careful when I look at the output of independent samples t-test because it is slightly tricky. It is not as straightforward as some of the other analysis. Independent samples t-test. Here, when you look at the rows, there are two rows. First, it says equal variances assumed. Second one is equal variances not assumed. There are two portions to the table. This one big table can be broken down into two parts. The first part is Levene's test for equality of variances. And in the second part, you can see t-test for equality of means. Now, if I just take a step back and ask myself, my goal was to compare the means. Why am I getting Levene's test for equality of variances, though I am not requested for? Very, very interesting here. And let me just take a couple of moments to explain this. When we are doing independent samples t-test, we need to keep in mind that this is an example of what is called as parametric test. And in every parametric test, there is one or the other assumption. One of the most important assumptions when you're doing the independent samples t-test is the homogeneity of variance assumption. This becomes the prerequisite for you to conduct the independent samples t-test. One of the prerequisites is that we have to check whether the variances are the same between the groups or not. That's why the first row reads equal variances assumed. It reports F statistic. Spss reports the F statistic as 119 point something, and the p value is 0.000. Since the p value is 0.000, which is less than 0.05, I will reject my null hypothesis and conclude that the homogeneity of variance assumption is not satisfied. I repeat, the homogeneity of variance assumption is not satisfied. It is not legitimate here. Since we are violating the homogeneity of variance assumption, subsequently, the entire first row becomes redundant. I repeat, the entire first row, starting with T all the way to upper confidence limit, the entire first row here becomes redundant. I have to jump to the second row. Look at the description for the second row, equal variances not assumed. Now, I have to look at the second row. This is the T statistic value. The degrees of freedom is 344.26. And we also have the significance level, which is 0.000, less than 0.05. Now, this significance level is for the T statistic that we are displaying here. Since the P value is smaller than 0.05, I can reject the null hypothesis and conclude that there is strong evidence for us to infer that the average salary between the males and the females is significantly different in this data. Further, you can look at mean difference. It is a simple subtraction between the male salary and the female salary. Since the female salary is 26,000 odd and the male salary is 41,000 odd, if you just subtract these two numbers, you should be getting 15,409.862. The standard error is reported. We also have the 95% confidence interval for the mean difference of minus 15,409. What is the lower confidence limit? Minus 18,000. And what is the upper confidence limit? Minus 12,860. So the mean difference of minus 15,409 will lie within the upper and the lower confidence limit. Now, this is how we can interpret the output of independent samples t-test. Many times, people ask, it's a bit difficult for us to understand whether we have to look at the first row or the second row. How do we make sense of this? Let me just give you a simple example so that this becomes a lot clearer to you. Imagine that I am in Bangalore and I have to take a flight from Bangalore all the way to Delhi. Now, there are two options here. If the flight tickets are available, I can board the flight from Bangalore all the way to Delhi. Now, if the flight tickets are available, that is very, very important. What if the flight tickets are not available? If the flight tickets are not available, instead of taking a flight, what I will do is I will go by a train from Bangalore all the way up to Delhi. Now, there are two cases here. Whether the flight tickets are available, then you can continue in the flight. If the flight tickets are not available, then you look at option number 2, which is to go by the train. The first case here, when we say equal variances assumed, is like the availability for flight tickets. We are checking whether the flight tickets are available or not. If the significance level is bigger than 0.05, it means that the flight tickets are available. And if the flight tickets are available, you can continue in the first row itself. You can continue on your journey on the flight from Bangalore to Delhi. Now, the second possibility is that the flight tickets are not available. So if the flight tickets are not available, you can see the p-value will be lesser than 0.05. As in this case, 0.000, it is clearly less than 0.05. If the flight tickets are not available, what do? You can't continue on the flight. You have to look at second option, which is to take a ticket in the train, which is where I will be, the first row itself becomes useless. I have to jump to the train and look at the second row here. So this is how we can interpret the output of the independent samples t-test. So with this, I have come to the end of today's presentation. In this presentation, we have looked at the box plot, which is part of the EDA. Then we looked at homogeneity of variance assumption. We performed the Levene's test for equality of variances. We examined the F statistic. Finally, we looked at t-test. We also spoke about the assumption behind t-test, that is whether the homogeneity of variance assumption is satisfied or not. This is what I had for today's presentation. Thank you very much for watching today's presentation. I request you to subscribe to my channel and hit the like button. Thank you very much. Have a great day.